In this video, we're going to quickly go over some of the introductory topics on sampling distributions here in section 8.3. So the idea is that every time we take a sample statistic, right, that statistic is really just dependent on that specific sample. And so suppose you draw a random sample from a population, you could compute the sample variance S squared, right? But if you draw a different sample, you'll probably get a different sample variance, right? And this is why it's called the sample variance and not the population variance, right? And so these observations themselves, the observations of the statistic, can be thought of as being part of a sample itself. And we call the probability distribution of a statistic. So whether you're drawing and computing, sample mean, X bar, whatever, any probability distribution of a statistic is called a sampling distribution. So let's take a look at an example here of talking about trying to get some our heads wrapped around what a sampling distribution is. It's the probability distribution of a statistic. Suppose we are interested in the heights of UMD students. We take a random sample of 100 students and measure their heights. And so we have 100 observations, x1, x2, x3, yada, 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 all the way up to x100. All right. Okay, so that's the setup. And we could find the sample mean, right? Sample mean then. The sample mean, x bar, is just x1 plus x2. We'll add up all of the observations and then divide by 100. That can be calculated from the sample. Calculated from the sample. And so let's suppose that we do that and we get the average height. Suppose that x bar is 69.2. All right, let's just say it's 69.2 in this instance. So suppose we repeat the experiment a second time. Suppose we repeat the experiment. And the second time, we get x bar equals 68.8. The second time, we get x bar equals 68.8. 68.8. All right, well, it may be really hard to know what the actual average height is of all UMD students, right? But we've taken samples of 100 and then another sample of 100, and so which one is more likely to be the actual average height, right? Is it 69.2? Is it 68.8? Is it somewhere in between, right? What's more likely to be the actual population mean, right? And that's sort of what we're getting at here in terms of the idea of a sampling distribution. If we know the sampling distribution, then we can use these sample statistics to infer some things about the population. So repeating it twice is fine, but let's say we do it multiple times. If we repeat the experiment many times, the average heights x bar maybe, so we've got 69.2, 68.8, 67.4, 70.1, and yada, 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 right? We'll have as many observations as we need. These themselves are observations that are sort of forming a random sample. And so there's a probability distribution underlying this saying how likely is it to get some of these observed values, right? And that is your sampling distribution. That is your sampling distribution. The sampling distribution. It's the probability distribution of x bar, assuming the experiment is done many times. Assuming the experiment is done many times. Okay? And so again, a little bit of foreshadowing. The problem we're trying to be able to answer in the future is, if we do an experiment like this many times and we say we have these observed averages, these sample means, then what is the true population mean? Well, a naive approach might be to look at this and say, well, let's take the average of all of our observed averages. Take the average of the average. Seems reasonable. But more specifically, what if we knew the probability distribution of this, right? What if we knew, for example, that these numbers followed, a normal distribution, or say these numbers followed an exponential distribution? If we knew that these numbers followed a normal distribution or an exponential distribution or something else, right? Then if it's a probability distribution we're familiar with, we have ways of computing the expected value of that, of getting the true mean of this, okay? And that is some of the questions we're going to tackle in a future video. But for now, just setting up some groundwork to move forward here. Section 8.4 on the central limit theorem is a big one, and we will see you in that video.